Hello guys, today we will be discussing a topic named as stress from the chapter Mechanical Properties of Solids from Physics. First I will tell you about its definition, units, we solved dimension, types of stress, and we will correlate it with our day-to-day life. Before going to the book definition of stress, we can understand simply by taking an example of any object that we are surrounded with, or we can take an example of a human body as well. Suppose I'm gonna take an example of a cylinder. I just want to make it here to make all of you understand that I'm making a cylinder. You know that this is the bottommost area, this is the topmost area of a cylinder, and it is having the area of cross section as A in this direction. If I can apply three forces on it, from the topmost position I can apply force on this cylinder. I can apply from the lateral side force on the cylinder, and one more force we can exert, and basically that is exerting due to the molecules that are present inside the cylinder on its innermost surface. This is also force. So basically if we consider, the three forces are acting in this cylinder. Okay, so simple definition of stress is stress, I can write it as stress equals to force ओपन एरिया, दैट इज फोर्स ओपन एरिया. जितना भी आपका फोर्स लगेगा एक यूनिट क्रॉस सेक्शनल एरिया में, उसको हम फोर्स बोलेंगे. देन अब हम डेफिनेशन देखेंगे. द बुक डेफिनेशन ऑफ स्ट्रेस इज टेलिंग the restoring force acting per unit area is called as stress. The restoring force acting per unit area is called as stress. और आप if you remember, हमारे स्ट्रेस को हम रिप्रेजेंट करते हैं नीटा से. मोस्ट ऑफ द बुक्स विल टेल यू दैट रिप्रेजेंटेशन ऑफ स्ट्रेस इज दिस इन दिस वे. नीटा इक्वल्स टू फोर्स अपॉन एरिया. You can compare the stress with the pressure as well. Stress is approximately equals to the pressure. Okay, so force formula, like the pressure formula, is also same as the force upon area. Okay, and the dimension, if they both are having the same formula, so they must have the same dimension and same unit as well. The stress and the pressure formulas, units and dimensions, they both are having same. The next formulas of stress equals to restoring force upon area of cross section, और stress को हम S equals to F upon A भी लिख सकते हैं. और we can write the stress in most of the books, it has written neta in this way, like this. Neta equals to force upon area. Okay, then we are going to find out its dimensional formula of stress as well. जैसे कि we can take as we discussed, neta equals to force upon area, force equals to mass into acceleration upon area. Okay, we know that area equals to, that is acceleration equals to velocity upon time, and the velocity equals to displacement upon time. We know that the displacement is L and the time represented as t. We can write it as L t minus 1. We can write this in this way as well. So put this here, L t minus 1, और ये आपका t. ठीक, तो you will get this after solving L t minus 2. M remains as M, mass remains as M. Then acceleration we got that L t minus 2 by like area is length square, and after solving we'll get that M L minus 1 t minus 2. This is the dimensional formula of both the stress and pressure as well. This one, this is our, this one is most important for us. Then now we will discuss about the type of stress. This is the Pascal and unit of these are the units of stress. That is, first one is the Pascal, next is your Newton per meter square. For both, this is valid for both your stress and pressure. Now we will discuss about the type of stress. First one is a normal stress or longitudinal stress. You all knew about this. This is the normal stress, means this is the longitudinal stress. Normal stress is the longitudinal stress. That means the force and area of cross section, they are perpendicular to each other. Okay. Discuss. Here, the normal stress, if the force is normal to the surface, that means the force is normal to the surface. What does it mean? The force is normal to the surface. It is called normal stress. Again, I'm gonna take an example of a cylinder here. This is the upper surface, this is the lower surface. Area of cross section here A. If I'll apply one force from its topmost position in this way, you can see here that force acting in this direction and the area of cross section is acting in this direction. The angle between them, that is the theta, the angle between them, that is theta, is 90 degree. So this is what we called it as perpendicular to each other. The two vectors, they are perpendicular to each other, that is called normal. Hence, if the force and the area of cross section, they are making 90 degree with each other, that we call it as a normal stress. Then the next one is here longitudinal or shearing stress. If the force is tangential to the surface, it is called tangential stress. कैसे? हम अभी उसको एग्जाम्पल एक लेके समझते हैं. एक बॉक्स ले लेते हैं. बॉक्स में क्या करेंगे हम, लेफ्ट साइड से उसको फोर्स लगाएंगे, एफ फोर्स. ठीक. और ये एरिया ऑफ क्रॉस सेक्शन तो पता है आपको, दैट इज ए. If you see the area of cross section A in this direction, and also the force is acting in the same direction, the angle between them is, that is theta, equals to 0 degree. If the angle between the two vectors, they are 0 degree, that means they are called tangential stress or parallel stress. We can call it as the parallel stress as well. In some of the books you will get that. Tangential stress, what does it mean? Tangential is nothing but the parallel to each other. Two vectors must be parallel to each other. We call it as a tangential stress. Okay. Then the last one is volumetric stress. The definition, if you see, it is very lengthy one, but the concept is very simpler. What is it? What the definition is written? When force is normal and acting at each and every point of the body such that it changes the volume of the body, it is called volumetric stress or bulk stress. Okay, the definition is very lengthy, but we will learn it in a very simpler way. Suppose I am taking an example of a cube. This is the cube. ऐसा क्या करते हैं, हम इसको पानी में डाल देते हैं. पानी में डाल देते हैं इसको. ओके, पानी में डाल दिए हम क्यूब को. तो और फॉर एग्जांपल क्या हुआ है, ये जो क्यूब है हमारा, उसका वॉल्स परमिएबल है, परमिएबल टू वाटर है. तो व्हाट विल हैपन, वाटर क्या करेगा, एंटर कर देगा इनसाइड वाटर. व्हाट विल हैपन, द वाटर विल एंटर इनसाइड दिस क्यूब. एज ए रिजल्ट वो क्या करेगा, एज ए रिजल्ट व्हाट विल हैपन, the volume of the cylinder, or you can take it as the cube or any type of object, उसका क्या होगा, उसका साइज इंक्रीज हो जाएगा, उसका वॉल्यूम विल इंक्रीज, द वॉल्यूम विल इंक्रीज. हमारा डायग्राम ऐसा था एंड इट चेंज टू दिस फॉर्म. दिस इज व्हाट वी कॉल एज वॉल्यूमेट्रिक स्ट्रेस. when this will be possible when this will be possible when my force will be acting from inward to outward. My force will be acting from inward to outward. In this case, the volume of my object will be increasing. ठीक. And the next one, if it will happen, if same as that we discussed, if someone is just applying force from its outer side, outer to inner, from outer side it is applying force, so what will happen, the area of the cube will decrease. The area of the cube will decrease. You can see it easily. As a result, the volume of the cube, volume of the cylinder will decrease. This is what we call as volumetric stress. Two type of volumetric stresses. If you apply force from the outer side, If we apply a force from the outer side, the volume will decrease, and if we apply force from the inner side, the volume will again increase. This is all about the basic thing of a stress. This is very beneficial and very important for you um, to read the Pascal law. Thank you so much for watching.